is Bood Mo Jiggler. Oh, I haven't started the... Silly me. The title font on page 98 is Bood Mo Jiggler. All right. Everything on the left there, you all should be able to already do. Go. It should take 2 minutes max. Who's this Max guy? 2 minutes max. It should take 2 minutes, comma, max. 2 minutes maximum. Get it? I know, right? I'll be appearing here till the end of January. Tip your waitress. Every so often I actually get a kid in the class named Max. It's so much fun. I've had a Maximilian, which was way more fun than the Maxwell. And I've had another kid who was just Max. I'm like, it's short for Maxwell? No. Short for Maximilian? No. Your name's just Max? Yep. Weird. I thought Max Barker was a Maxwell. Maybe he's the one that's just Max then.
Maybe. I'm pretty sure we'll never know.
We won't because he's graduated. So I'll never see him again.
I mean, you will see him again.
Probably not.
Depends on if you come
250 kids graduate every year. No orange. I am not glad you didn't say banana.
Never say never.
All right, you guys done yet?
No.
Oh, God. I said 2 minutes max.
Okay, well,
No, I'm getting mad. Mad Matt? I know. I do that on purpose because when I ask kids about the first two, they always say he.
but it's a female. Yeah.
Now, it should, of course, nowadays be at what times did the diver stop their descent. But that is grammatically appalling because there is not more than one diver. But I prefer that to zim and z and zer. So I hope that that is what wins in the pronoun wars. I, of course, worry about how many things that are wrong in the world, and we continue to fight about things like pronouns. But that is just me. No, you were only doing everything on the left of number one because we are going to do a whole bunch more work with stuff on number one. That's why there's all that empty space right there. I think you know how I work now, Raj. All right. What is the IV and the DV? IV is time. Why? No, that is not the right answer. No, again, I'm saying that's not the right answer because if I turn the diagram, it still has the same data. Yes. The depth depends upon the time she spends in the water. Are any of us underwater right now? No. Is time passing for us? Yes. So that is the first thing. That is the real reason. And the dependent variable is the depth. Ooh, I spit a lot when I said depth. It's a hard word to say without spitting. Just ask Gary Oldman. He's the guy that was acting with Joey in that episode of Friends when they were doing the play and spitting all over each other. If you haven't seen that episode, it's a great episode. Okay. Next thing. It's not any... we'll talk about that in a minute. How many minutes did the dive last? 30. Good. I didn't fool anybody. A lot of kids say it 29 because it went one square past 28. Then they don't check that each square is worth how many minutes? 2. Excellent. At what times did the diver stop her descent? She stopped at 4 minutes. And she stopped at 10 minutes. How do you know that?
Because it's straight. There's a graph showing.
It is a flat line. Time continued on, but her depth did not change. She found Nemo there and Dory there. What was her greatest depth? 20 meters. How long did she spend at this depth? 4 minutes. What is the domain and range?
I got it.
What is it, Mantosh?
Domain is 0 is greater than or equal.
Less than or equal to.
Equal to x, which is less than or equal to 20.
I would write time as opposed to
20.
x.
Okay, and then I wrote the hard bracket. Oh, like after that's 20, and then
It's 20 for domain.
I think so.
It's 30 because domain is time, right?
Oh, yeah.
And the other way to write that is, of course, yes, with a hard bracket. And what is the range?
The exact same thing except 20.
Except 20. And I would write depth here. All right. Oh, I ran out of room for my brackets. Now, before we write anything more down, we need to talk a little about this. Is this graph, and I've said this before, I would like to see how many people are paying attention. Is this graph a drawing of what actually happened? No. Because what actually happened is, and don't draw this, there's ocean, there's a boat, there's a diver, air tank, snorkel, bubbles, and the diver went down. And the graph went up. Is a graph a drawing of real life? No. It is a drawing of data. First lesson. Now, let us move on. This graph tells us a whole bunch more than what you have discussed on the left here. All right? Let's talk about what that tells you. This graph, you could split it into how many sections? Abner says 2. You could split it in 2 because she goes down to a bottom depth and comes back up, yes? Okay, so we would split it about there, yeah? Or would you split it on the red line? Because that's when she starts coming back up. Red line? Okay. So right away, we have a discussion that we got to consider these times, yeah? Because nothing's really happening there. She's just chilling. So I would submit we can split it into 1. We can split it into, let's get another color that will work on this gray here. We can split it into 2. And we can split it into a 3rd. Because these two, nothing really is going down, yeah? She's a diver. She's staying flat. All right, now, on the blue section here, what do we know is happening? She is fallen out of the boat and she is swimming downwards, yes? That is what is happening. Can we gain more information from this graph than that?
Besides how long it takes her.
We know how long it took her. How long did it take her to do this first section before she took a break? 4 minutes. Do we know what something else about that first 4 minutes? She went to 12 meters of depth, yes? Well, meters a distance, isn't it? And she went 12 meters in a certain amount of time, didn't she? Do we ever measure a distance compared to a time? When? Driving, kilometers per hour. So does this graph also give us the speed at which she descended? How? She descended 12 meters per 4 minutes. Now, do we ever write speeds that way? What's the speed driving around the city? 50 kilometers per hour, right? Would we ever say the speed in Abbotsford is 200 kilometers per 4 hours? No, that's idiotic, right? Speeds are in what? Terms of one thing, yes? So we don't want 12 meters per 4 minutes. What is her speed? Mantoge. 3 meters per minute. And we got that from our graph, didn't we? All right, then she took a break. She's tired. What happened here? She continued to swim deeper. How far? 8 meters, but in how many minutes? 2. Is that a speed? It is, but is it a way we would measure speed? No. What is it?
It's 4 meters.
4 meters per minute. Which was faster, blue or green? Green. Look at the two lines. Let's compare them. How would you compare, using one word, that green line to that blue line? I just want some different words. I've got one. There's distance. Division. Okay, what else? Steepness. What else? Angle. Angle's pretty related to steepness, right? We would argue, right? That's what makes something steep. You give it an angle, right? So those two are good. You already had your turn. Connor. What? Speed. Okay. But again, we've decided that the green one is faster. We're talking about the lines now. So I like the angle and the steepness one. Because which one is faster? Green one. And which one is steeper? Green one. Why? Did I take up more distance in less time? Isn't that what makes you fast? If you can cover a lot of distance in a little bit of time, you are going fast, yes? Excellent. So that leaves us with this third one. Something weird is going on over here, though. She's ascending, yes? Okay. How far does she travel? 20 meters in how many minutes?
14 minutes. No. 16 minutes. I think. Yeah.
20.
Yeah, 16 minutes. 30.
It is 16 minutes. Now, that's no good, right? What would it be? How did you get 3? 12 divided by 4. How did you get 4? 8 divided by 2. So how are you going to get this one?
5 meters per 4 minutes. Yeah, that would be, yeah.
But we don't want it per 4 minutes. What did I... 1?
1.25 meters.
There you go. 1.25 meters per minute. That's what I said, 1.25. Yeah, 1 1/4. It's cool. Whatever, right? Now, actually, that's where we're going to stop that. Everybody cool? This piece of math is called finding the rate of change. You haven't, unless you've done it with somebody else. I have not done this with you. So, the rate of change is very simple. It is, everybody draw that triangle. That triangle is a Greek letter. It's delta. It means change. It is the change in your dV divided by the change in your IV. So in this case, our dV was depth. It changed 12 meters over the course of 4 minutes of change. I do that division, and I get my rate of change. Now, in this case, because it was a distance and a time, that's a speed. Everybody understand? Now, what if I had a big bowl of M&Ms? And in that bowl of M&Ms, there were 1,000 M&Ms. And you came back 20 minutes later, and there were 700 M&Ms. What is the rate of change at which I am hoovering back those M&Ms? How many M&Ms did I eat? There's 1,000 there, now there's 700. How many M&Ms did I eat? 300 in 20 minutes. How many M&Ms am I eating per minute? 15 M&Ms per minute. Everybody understand? So it's not a speed because the M&Ms aren't going anywhere except into my belly. But there is still a rate of change, isn't there? Every 15 minutes, every minute, there's going to be 15 less M&Ms in the bowl. Everybody cool? That is a lot of M&Ms. All right, let's go down to this page. Now, let us look. We're still on page 98. This graph shows the volume of water in a watering can over time. Is this graph a drawing of what happened? No, but something happened, right? Tell me a story. This is not English class. I do not need a protagonist and an antagonist. And I do not need to know what kind of conflict is being sought after, person versus person himself, or person versus environment. I do not need any rising action. I do not need a climax. I do not need a resolution of the conflict, nor do I need a denouement. All I need is a possible explanation for what happened here. Go. Write it down. Because there's something, I am going to do something with this. If you would be so kind as to try and cram it in over here. Meanwhile, I will be writing an actual scenario to do with watering cans and water. Uh-huh. Are we ready? Well, again, it's not a novel, Simmer. I just need a couple of sentences. There's only 3 sections of the graph, right? So you only need 3 sentences. I'm sure you are. I make sure you really flesh out the characters because this is English class. There we go. That is a true story because that's what big brothers do. That's what big brothers do. Yes. I am well acquainted with Riley's elder brother. I am surprised because he has been in this class and has seen that story. I'm surprised he hasn't done it to her. Yes. All right. So, now, ladies and gentlemen, you know that you are existing in a milieu in school whereby you are graded on a sliding scale. That sliding scale for you people is 0 through 7. Now, you are also aware that even though I am not a giant fan of it, am aware that every single thing is now being graded upon rubrics, which I do not like. Because 9 times out of 100, nobody puts a 0 on a rubric. which means it is impossible to get nothing even if you don't do the job that you have been asked to do. And secondly, rubrics work wonderfully for a lot of things. But in math, x equals 7. If it isn't 7, no amount of rubricing will make it right. But because I am forced to follow everybody else's, and we always throw in education, we throw the baby out with the bathwater, I know that I am being forced eventually to start grading in such a method. So I am going to every so often experiment with that type of grading with you. If I were going to grade your explanation of this scenario, I would put it on a 4-point scale. The first point would be 0, in whereby you do not explain this at all. Okay? You have not done a thing to explain this situation. I have no problem saying this kid does not understand this. I am giving this kid 0. I am not like the English people in England who gave a kid 1 out of 6 because on his final grade 12 exit essay from high school, he wrote F-U. He did not write F. But because he put an exclamation point, it was a sentence. And they gave him 1 out of 6 because he proved he could formulate a sentence. Unfortunately, I do not subscribe to applauding that. I think that kid should have been made to do the entire year over again because the kid did not answer the essay question. But of course, there are many people in the world that think that kid is brilliant. Just like the kid that when the teacher gives them this and the questions say find X, the kid circles it, and your teachers show that to you like that kid's a genius. No, that kid's a tool. But that's beside the point. Let's go to math. You want 1? You want 1 out of 4? There's a watering can, and then it got dumped out. Everybody with me? Because that's what happened, yeah?
Yeah.
Okay. You want 2 out of 4. A partially filled watering can is carried to another spot and emptied to nothing. 2 out of 4. Yes, Harry.
No, okay. But you have it filled up, right? What if I said it's getting filled up and then you said after?
I'm just...
Well, like the first line, is it going from down up or just stays there?
I don't think I know what you're talking about.
The chart is confusing right now.
Why?
Okay.
There was 1 liter of water in the watering can, and then 20 seconds later, there was 1.75 liters of water in the watering can. What is the only thing that could have happened? It got filled. What happened here? No water was removed nor added while time went on. And then what happened here? The water was emptied. Now, 2 is the one I just described. 3 out of 4? Throw some numbers in there. A watering can with 1 liter of water has 0.25 of a liter added to it. 40 seconds later, the watering can is emptied. 3 out of 4. Do you want the 4 out of 4 where you exceed my expectations? Then you tell me every possible thing that happened. So, let's do that, shall we? A watering can with 1 liter of water is filled at a rate of, I went up how far? 0.25 liters in how many seconds? 10, 20, 30 seconds, yes? Would we ever give that as a rate? What would be the rate we would give? Per second or per minute? Which one makes more sense when I've got 30 seconds on the table? Per minute, because all we got to do is multiply by what? So it's filled 0.25 in 30 seconds. What's it filled in a minute? At a rate of 0.5 liters per minute. Then it's carried for how long?
40 seconds.
For 40 seconds. And emptied at a rate of what? How do I figure it out? How much went away? 1.75 liters in how much time? 20 seconds. Would I ever give that as a rate? Should I use seconds or minutes? So what do I multiply by this time? 3. 1.75 times 3 is? 5.25. Does everybody understand? What happened? Watering can filled up and emptied. Right? Do you see the difference in quality of answer? What will your IB masters want? Will they want this, or will they want a filled up a watering can and then I dumped it out? Which one's right? Both of them. Which one do you want? The first one. This. Not I filled it up and I dumped it out.
What if you say someone went and put more water into the watering can and someone just drank it?
You drank out of the watering can? That's kind of grody, but if that's what you want to do, that's fine. Straws are even more grody. All right, are we good? Okay, turn the page over and let's see what you bring to the party. Now listen to me carefully. Talk to your neighbor. Attempt to draw this graph. Listen to me. Draw it in pencil. Because 90% of you are going to make an error. Even though I have just told you that, and you will be on the lookout, you will probably still make this error. Go. No. I will tell you the error. Because, Avnor, you have been around long enough to know what does this much white space mean. We fix that error. Go. This is all we're going to do today. We're going to finish this page. It doesn't really matter as long as you tell me. So, 1, 2, make them a little bigger. Nah, they were fine. 1, 2, 3, 4, 5, 6, 7, 8. Everybody agree? What should I put on the y-axis? Measured in what? I'm going to go ahead and go up by, I'll use 25. Now, do I have to mark every one? Of course not. I've shown you 1 is 25 and 4 is 100. So now I'm good. 125, 150, 175, 200, 25, 50, 75, 300, 25, 50, 75, 400. Everybody happy? All right, now I'm going to use colors here. First 2 hours of the trip, Jack leaves home, travels 140 kilometers at a constant speed. So in 2 hours, how far does he go? 140. 100, 125, 150. Everybody agree? 2 hours, he went 140K, yeah? And since it's a constant speed, would it look like this? No, of course not. What would it look like? Straight line. Now, is that really possible? No, there's stoplights and things along the way, but, for argument's sake, we're going to say it's constant. Everybody agree? All right. How fast was he going? What? Yes, it does. 70 kilometers in an hour, right? Because it's 140 in 2 hours. We don't do speeds that way. Everybody cool? Yeah. All right. Jack visits Grandmama for an hour. Does Jack's distance change for that hour? No, because he is sitting at Grandmama's having tea and tiny sandwiches with the crust cut off them. Yes? Flat line till 3 hours. Now, here is where, if you are going to make the mistake, you make it. Jack drives back towards home. How many of you went that way? Be honest. Why? Because it says he's driving back towards home, yes? Okay. So we're going to finish that graph, even though that graph is not correct. Okay? So, we're going to explain why, don't worry. 50K back towards home. Can we assume he is traveling at approximately 70 kilometers an hour? Yes. So we're going to keep about the same level, 50 kilometers. He's not going to quite go 70K, is he? So right now we're at 140. He's going to go back towards home like that, yeah? And then he's going to stop for 30 minutes for supper. So what do we do for that? A flat line for 30 minutes, yeah? And then I'll use the brown ink to go home. Now, he takes 2 hours to get home after this first little bit. Will the next line be steeper or shallower than this red line? Shallower. Why? He takes longer to go less distance, yes? So from here, he's going to take 2 hours. So we're at about 4.5 hours. So he's going to come out to about 6.5 hours. And it's going to be shallower than this one. Everybody cool? Your graph should look something like that if you read exactly what he said. Because all of you said, he turns back towards home. Right? Now what the graph really should look like, and I'm going to change shades slightly. I should have gone up at the same level, flat, and then in a different shade. I don't have a different shade of brown, so I'll use that. Up like that. Now, stop. This line is a distance time graph. Because of what I'm about to explain to you. Distance time. This line is what we call a displacement time graph. And I'm going to use a visual display to show you the difference. All of you have to buy into this or it doesn't work very well. Close your eyes, please. Everybody's eyes are closed or hiding behind their bangs like Connor? Everybody's eyes are closed? Yeah. Count how many steps I take. Is everybody ready? Yeah. Eyes open. How many steps did I take? 4. Absolutely correct. Now, you all know that I traveled 4 steps, don't you? Because you could hear it. Did I, when your eyes open, appear to have traveled anywhere? No. If I had gone like a ninja, you would not have known how far I traveled. Which of those is distance? 4 or nothing? 4, because I traveled 4 steps. 2 that way and 2 that way. How far was I displaced? 0, because I'm back exactly where I started. Does everybody follow? All right. Now, we're going to do some writing, and then we're going to do another visual aid. So, in that white space down below, right here, distance is a scalar, which means it only has a magnitude. Magnitude means size. How far did I travel? 4 steps. You heard them. You know I traveled 4 steps. That is a distance because it only has a size. Displacement is a vector, which means it has magnitude and direction. Now, in the real world, how many directions can I travel? Infinity, right? Because I could go diagonally that way. I could go diagonally that way. I could go 1 degree off of straight east. I could go diagonally backwards. Everybody understand? In math, how many directions are there? What do we use to measure things in math? Numbers. How many directions can a number have? No. 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 You're getting warmer finally on the 7th guess. No, it's the 7th guess that I've heard from everybody, not you, RJ. Calm down. Okay, so what do you mean by that? Okay. No. Every number. What are the only directions numbers can go? Not left and right. Positive and negative, finally. In math, you said up and down and left and right. In math, every number has to be either positive or negative. Math is binary, yes? Oh, the way we count is, right? So, let me ask you this. If I can only have 2 directions in math, but I can have infinite directions in real life, how do we reconcile the two? Well, we know that a displacement has to be positive or negative, yes? So we have to make some decisions. We don't make those decisions. Other people have. Math folk have decided that positive are things like north, east. Now you can start saying that stuff. Up, right. Okay? Everybody cool? North, east, up, right. That's good enough. What then are the negatives? South, west, down, left. Now, more importantly for us, positive means away from a starting point. And negative means return to a start. Now, you're smart kids. Where is my right? That way. So for me, 1, 2. 2 positive steps in displacement, yes? 1, 2. 2 negative steps in displacement. What is my displacement? 0. What is my distance? 4. For you people, when I go that way, what is that for you? Negative, because I went to your left. And then positive, because I went to your right. Which is why we have this part of it. Because the point of view of the measurer will change this, yes? So when I leave my starting point, I am gaining displacement. When I return, I am going back. That is why the bottom line is the displacement graph. Does everyone understand? All right. That is where we are stopping today because you think you understand the next graph, but you don't. We will take this up again Wednesday. Pages 86 and 87 that I talked about at the beginning of today is due Wednesday. Because you're writing a cumulative tomorrow. Aye? Do not forget to put your chairs up. It's almost like I timed that perfectly again. Woo!